Hello students, today I discuss a function of several variables, especially two variables of several variables is a topic from real analysis, very important one, and this is very important for if you are preparing for master degree, MSc, BSc, or SET, NET, GATE, SET, NET, GATE, very important. Let's watch. Various competitive exams. This is important. So let's start this topic. First, I introduce what is the definition. And definition is we say that z is equal to z is a function of two independent variables x and y, where x and y are independent, where x and y are independent variables. Are independent variables. Variables. Then so if you take a certain range where xy belongs to x and y both belongs to in a certain range, in a certain domain, belongs to domain which is a proper subset of R2 second two-dimensional space, then this range, for this range z must have a finite a definite value. It must have a definite value. Have a definite value. So if uh, uh, for each pair of xy, or for all pairs of xy belonging to uh, the domain D, z have just only one value. Z has only one value, then z is called single value function. And if there is uh, many values, and if there are many values, many values, then z is called multiple valued function. Set multiple valued function. Now this is the introduction to the function of several variables. Here I have taken two variables, just x and y. You can take more than two variables. And the definition is same. Now let's go in another one topic. Now we know some limits related with function of several variables. So some important limits, just different. Then we know. First we know simultaneous limit. Simultaneous limit. This kind of limit are called simultaneous limit. If if we take that the function f(x,y) which is a function of two variables uh, in a two-dimensional space, as a limiting point, as a limiting point, limiting point, limiting point x0, y0, then the limit and together, this is, that's why this is called simultaneous. X tends to x0 and y tends to y0, simultaneously taken two limits of fxy is called simultaneous limits. I will later provide the information and the behavior of the simultaneous limits. So this is the this is called simultaneous limits. And what is iterated limits? Iterated limits are if fxy is a limiting point at x0, y0, then there can be uh, two cases. Either we will use two limits on fxy, but the order will be reversed. First we can take this limit x tends to x0, and again limit y tends to y0 fxy, and another it can be that limit y tends to y0 and limit x tends to x0, fxy. These two types of limits, iterated limits. So both have the limiting points x0, y0. So this is the introduction to the simultaneous limits and iterated limits. Now let's go the behavior of these limits. So how we can say that the existence, how the existence of the simultaneous limits can be defined. Existence of simultaneous limit is the condition required we can say that limit, the simultaneous limit x tends to x0 and y tends to y0, fxy exists and is equal to limiting value L if every epsilon greater than 0, very small, but just greater than 0, there exists a delta which is also very small but greater than 0, such that that mod of fxy minus L less than epsilon for all values of x and y in the neighborhood of in the neighborhood of x0 y0 defined by, they have to satisfy, defined by mod of x minus x0 less than delta and mod of y minus y0 less than delta. How you can explain this existence rule for the simultaneous limit? So or if we take a space, a Cartesian plan, two-dimensional plan, if this is fxy, I am taking a curve. If this is fxy, this is the point fxy, then uh, and its limit point, I am taking, this is L, this is the L, So the distance must be this distance must be less than epsilon, means there you can find out that that this will be x0 y0 actually. This will be x0 y0. So if we take in this way more bigger circle, so if this is fx0 fx0 y0, so and the radius is epsilon, then in the neighborhood of x0 y0, uh, we have to also satisfy that L must belong on the on the uh, area of this circle. So L must belong in this area of the circle. So L belongs in any point in this circle or in the neighborhood of fx0 y0. But we need to have this limit continuous. We need that x minus x0 must be less than delta. So it is very hard to draw in two dimensional. Actually, it is a matter of three dimensional. So it is very hard to draw in two dimensional. X minus x0 must be less than delta, and y minus y0 must be less than delta. Then we have the limit value of this function fxy at the point x0 y0 will be L. So now go to the another on this point. Take now I'm giving an example that this limit, the simultaneous limit I'm taking at the limiting point 0 0 0 0 x y square x square plus y square. So we have already defined that what is the necessary condition for being the simultaneous limits existence. So we have already defined. So we find out that does it exist or not. Its existence is in question mark. So we will verify this. How we can verify this? Take we are taking that y is equal to mx. If y is equal to mx, then if y tends to 0, then x tends to 0, we know this. Then we can just change this limit to x dependent. Then it will be x tends to 0 and the limit will be changed x into m square x square, and here will be x square plus m square x square. Now look this limit x tends to 0, this will be uh, x m square plus 1 plus m square. So here we are getting 0. So we can say that its limit exists. But we have taken the straight line y equal to mx for this. To verify this limit existence, we have taken a straight line y equal to mx. Y is equal to mx. If we take another curve like x is equal to y square, if we take another curve x is equal to y square like this, x is equal to y square, then we will have different limit point. So any limit does not cannot have the two limits. So we can first check this. If we take x is equal to y square, its limit will be changed. We have already found limit point is 0. Now we can get that x y tends to 0. Here it will be y to the power 4. Here it will be y to the power 4 plus y square. So it will be limit y tends to 0 y square plus 1. So here question this will be satisfied. Here its existence. I am proving this. This is y square. Uh, and this will be y square and y4. Here it will be this 1 and its existence. So here the limiting values are same. So it exists. But what it will be if we change it exists. This exists since through a straight line we must have simultaneous limit exists, but through another curve another way, if it has the same limiting value, then we can say the simultaneous limit exists. But if we change this example this way, change this, if we take limit x tends to 0, y tends to 0. Now we are taking xy cube plus by x square plus y to the power 6. Then does it exist? Again we will verify through x is equal to y is equal to mx. Then what will be? Then it will go limit x tends to 0 x into u into x cube by x square plus uh, m6 x6. Then it will be limit x tends to 0. This will be x square m cube by 1 plus m6 x6. So this will be 0. And if we will take x is equal to y square, then what will be? And then it will be limit y tends to 0. X there will be y to the power 5, and in the below it will be y square y to the power 6 getting x is equal to y cube. Here it will be equal to 0. Then we will change y cube. Then it will be y6. And we have x square. So this will be again a y6. And we will get again y6. This will be 1 by 2. So here we can generate two limiting values. This is our way to verify. It is our way to verify. How we can verify that we have a single limiting value, or we can generate two limiting values for two different waves or etc.